Hi, welcome back to Physics Teacher, the channel that prepares you for the Waterloo Math and Science contests. In this Fermat question, the last question on the 2021 Grade 11 Math contest, which makes it quite a challenging one, we have a certain number of triples, where those triples are listed in increasing order and their product must be equal to all of these prime squares. What's the remainder of all those possibilities when divided by 100? Give it a try, and I'll be right back with the solution. Alright, so to start, I'm going to create a new set of triples, A, B, and C, where A, B, C, the product of A, B, C, is equal to all of these prime squares. And the reason why I'm doing that is because I'm not going to consider this increasing order yet. I'm just going to consider every single possibility for these triples A, B, C that would be equal to these products of prime squares. So first, if we look at 2 squares, well, what that means is there's 2 factors of 2. And therefore, we have a certain number of possibilities. One, A and B could give us those 2 factors of 2. A and C, B and A, BC, CA, or CB. So that's a total of 6 different possibilities of where we could get these 2 factors of 2. And the same is true for these 2 factors of 3. We can have the same possibilities, 2 factors of 5, and so on and so on. And so there's a total of 8 primes here. That means we have 6 to the power of 8 different possibilities of A, B, and C. All right, next we want to make sure that these are all different values, right? X does not equal Y, Y does not equal Z, X does not equal Z, and so on. Well, we know all 3 values will not be the same. This is not possible, and the reason it's not possible is because it's not equal to a perfect cubed. These are all squares. They're not a perfect cube. So this is automatically not going to happen. But what I want to check is all the possibilities where 2 of these values could be the same. So, for example, let's say A equals B. And since A equals B, we do not want A to be equal to C, and we do not want B to be equal to C. So this is one case where 2 of these values will be equal, but not all 3. And that'll be true for each a prime squared factor, which would mean that each prime squared factor is either distributed to A and B. Right? So if we call this 1 prime squared factor, P squared, these are all prime squared factors, right? A could be one of those prime squared factors, and B could be the same prime squared factor, P, but not to C. Or the other possibility, right, is C can be both prime squared factors for each one of these prime squares. So that means there are 2 ways, 1, 2, in which we can distribute each prime squared factor. Could call them, for example, P1 squared and P2 squared and so on, right? So if this is for P1, we have these 2 possible ways to distribute that factor. Well, then we would have the same 2 possible ways to distribute the second prime factor, and the same 2 possible ways to distribute the third prime factor, and so on and so on. So we would have a total of 2 to the 8, since there are 8 prime squares, possible ways to distribute our prime factors, to where A and B would be the same, and neither is equal to C. Well, there's other ways that we can have 2 values to be the same. We can have B equal to C, and neither B or C is equal to A. And then we would have the same 2 to the 8 possibilities to distribute each prime factor. Or we could have A equal to C, but neither of them equal to B. So the total number of ways that we could have two of these, either A, B, or C, two of those variables equal to each other is 3 times 2 to the 8. So if we go back up to the total number of possibilities, we have 6 to the 8 total possibilities for which A, B, C will equal this. And then if we subtract 3 times 2 to the 8 possibilities, then we have a total number of possibilities where the product of A, B, C is equal to the product of all these prime squares, where no two of A, B, and C are alike. So now that I have different values or distinct values for A, B, and C, now we need to put them into this increasing order. And there are different ways you can do that. So for each value of A, B, or C, so let's say you had one possibility of A, B, and C, well, we could put them in different orders. We could do this, or we could rearrange it to this, 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 and you can see that there's going to be 6 different possibilities here for which we can order A, B, and C. But if A, B, and C are all distinct, for example, only one of these is actually going to be in increasing order. So only 1 out of every 6. So what we're going to do to find the total number of triples n, where x, y, and z are positive integers and all distinct so that they are also in increasing order, is we'll take the total number of possibilities for x, y, and z to multiply to give you this product of primes, minus the total number of possibilities where any two of these variables can be equal to each other. And then we're going to divide that by 6 to make sure we only look at the one that is in increasing order. And so when we do that, when we calculate that, we get a total of 279,808 possibilities. And when we divide that by 100, we get a remainder of 8. So our answer is C.